right, so I'm live here, 52 weeks of AWS. I'm continuing to cover the Solutions Architect certification material. And today I'm going to talk about securing user and application access, probably one of the most timely topics that we can discuss for cloud computing. There is a lot of increased risk of cybersecurity threats in the world right now, and there's conflicts that could potentially make your organization really need to care a bit more about cybersecurity. And so this is a great topic for today. So let's go ahead and dive right in here. I'm going to talk through this material on securing user and application access. I'm going to go ahead and share my screen if you're watching live here with video, and let's get to it. Okay, so first up, securing user and application access. We're going to talk about some of the things like architectural needs, the user account and IAMs, how to organize users, do federated users, multiple accounts. Also play around a little bit with AWS itself and do some demos if it seems like it's needed. So by the end of this talk today, I'm going to cover IAM, groups, roles, how to use user federation, also about AWS organizations, and how to manage multiple AWS accounts, which is, in fact, a really good process for many organizations. Okay, let's get into architectural need first. So, that's typically a good place to start is what's the structure of your company, what it is you need to solve, then move into the details. So the first thing that most people don't do that they should do when they're using AWS is they need to secure the root account. I've personally seen this happen at multiple companies where everybody was using the root account initially because it's a startup and we want to move fast and break things, or like I like to say, move fast and break democracy. But in general, with root users, you need to secure them immediately because it's so easy to essentially give someone access to your account, and then now you don't have a company anymore. You've given it away to other people. And the first thing to do would be to create a admin user account. The next thing to do is make sure that you lock away the root credentials, and then don't use the root account, period. So instead, what you would want to do is use the admin or specific admin users, maybe an admin for S3 or an admin for compute or something like that for most of the tasks. So IAM is a way of managing identity and access management. You can securely control individual and group access. You can integrate with other AWS services, do federated identity management, granular permissions, and also MFA or multi-factor authentication. Okay, what are some of the components to review here? I think one of the big ones to be aware of is this concept of, being able to create a user, right? That's probably the biggest of all, is be able to say who's going to do what in terms of the user accounts. And then the next thing would be to group those together, right? So you would have maybe the data science team or the software developers or the product managers or whatever teams you want to build. And then you can apply the policy to that group. That's typically a best practice, is to, create a group that has some type of role in an organization, and you use something called PLP, principle of least privilege. So you don't give everybody admin access. You just give that group the access they need, and it's better for them and it's better for your company because you don't want to create unnecessary vulnerabilities. The other thing to be aware of is something called IAM policy, and you can assign a policy as well that actually restricts things on a basically what resource can be accessed and then the level of access to each resource. So for example, S3, you could define a policy that says it's read-only. The other thing that's really commonly used for AWS is this IAM role concept. And this is a way of granting temporary access to a resource. Like, for example, the EC2 instance that you launch, if you create a role where it can access read-only S3, that would be a perfect use case versus taking some developer in your company, making API keys, putting those API keys onto an EC2 instance. That's that's a bad practice, right? That's a worst practice, not a best practice, because if that developer leaves, now what do you do? Even if you trust the person, which is probably not a good idea to trust people that are not in your company anymore, but if you are going to leave that resource running, you now have to figure out how to manage the production aspect of that key. Do you remove it? What do you want to do? So the role-based privileges solve the key on the server problem. Okay, so that's IAM in a nutshell. What about permissions? So permissions are defined in an IAM policy. This would be in JavaScript object notation or JSON. And the best practices, as I mentioned before, is follow the principle of least privilege. There's two types of policies. There's an identity-based, so you attach it to an IAM principle, and there's resource-based, which is you attach it to an AWS resource. For example, how IAM determines permissions at the time of request. Is the permission denied? If it is, then you don't go any further. If it's not, you then ask, is the permission explicitly allowed? Yes. Otherwise, you deny. So identity-based versus resource-based, what's the big difference? Identity-based is attached to a user, a group, or a role. These are AWS managed or custom managed or inline. Resource-based policies are attached specifically to a resource. For example, if you created an S3 bucket for your data science team, you may put some specific policy, like maybe the data science team can only read the data in the bucket because there's no reason for them to mutate that data. If they're going to train a machine learning model, they put them into a different bucket, and that would prevent potentially data integrity issues for maybe really important data you have in your company. So IAM policy document structure, this in effect can be either allow or deny. And so the type of access that's allowed or denied would be, let's say, S3 get object, or in the case of resource, it could be specifically some resource like a queue, SQS. And then the condition would be something like the username. It would be the resource that the rule must apply to. So ARNs and wildcards, you see this a lot with AWS, is that resources are identified by using the Amazon resource name or ARN format. And so if you're going to access, I don't know, a queue or a Lambda or a step function or something like that, you would use this syntax, which is ARN : partition : service : region : account : resource. So that's really the shortcut here. An example would be, in this particular example that AWS is giving me, is ARN : AWS : IAM : 1 2 3 4 5 6 7 8 9 0 1 2 : user / MMAJOR. So that's really the thing to be aware of with the ARN format. You can also use wildcards, though, to give specific actions for a resource. For example, S3 star or IAM star, access key star. Okay, so what is a policy example like? So at the very top of the policy statement, you would say what the effect is. So let's say effect allow, and then you would say DynamoDB, S3, and then you would put in potentially the ARN, and then you would have maybe the bucket names, and then you could have below that an explicit deny that says, for example, these kinds of things, are the things that I want to explicitly deny. So in a nutshell, with IAM policies, if I just go through here and I go to my account here in AWS, and I go ahead and I type this in, you can see here that you can actually go through in the front of the console, and there's a bunch of different things that you have in your first presentation. You have user groups, users, roles, policies. And so if I click on policies, I can go ahead and I can create a policy, and then there's an editor where I could go through and I could edit things, or I could just go to JSON if I'm an expert and just put those things directly into a policy. Okay, so one of the things that you'll be asked on certification exams is you will be shown, for example, sometimes you'll look at a policy and then you'll have to explicitly explain it. And so this is just a good thing to be aware of, is that you should look at some policies and just make sure you understand how those work. CloudTrail is really one of the most fundamentally important services for security in AWS. Why is it so important? Well, it's because it is what logs and monitors user activity, and it provides an event history for AWS accounts. So this would be things like AWS Management Console, SDK, AWS CLI. It also increases visibility into user and resources. It has a 90-day event history by default. It shows who accessed your account. So that's really important if you wanted to look at maybe some rogue API calls, like who's doing this. It'll explicitly tell you who did it, when and from where, and then also what is it that they did. And it's a helpful tool to do security analysis, and then also figure out if there were calls that were blocked, for example, like were your IAM policies really working, which is a great way to test your security, right? Is to make sure that they are blocked when you have them blocked. So if we go over to CloudTrail here and I take a look at it, you can see an example here is that basically I could go through here and look at all the different events in the event history. We see that there's a console login, there's a log stream, put evaluations, all these kinds of things you can look at, which is pretty nice. You can even look at things like insights, where it may tell you some, neat little things like, oh, look at this, you're getting some kind of behavior. Let's go ahead and take a look at it. So it is a great centralized resource that allows you to dig into the details of what's happening with your system. So really a must-have first step to investigate security on AWS. Okay, let's talk a little bit about IAM groups, which is a way to grant the same rights to multiple users. So instead of having, at a Fortune 500 company, it would be impossible to give every single person that comes in, maybe into your company, specific, permissions. In fact, it would be a bad idea. In fact, a security hole, because if you're explicitly giving everybody one-off permissions, you're going to create a error at some point, and then you've given somebody too many permissions. And then at that point, you have a vulnerability. So the best way to do this is to basically have a group that has a job function associated with it. Again, data science would be a good one, where you would have potentially maybe read-only access to S3 and ability to talk to SageMaker, and maybe you can also work with Athena or something like that. You put those all together into a group, and then when someone new comes to the organization, you go ahead and you give that member access to that group, right? So that you're not making mistakes every time you explicitly give a particular user permissions. So some of the things that you could see in a group level IAM structure, you could have group admins, group developers, group test. And so maybe a new developer is hired, you add them to the developer group. If a new developer is in a different role, then you add them to their new group. So really, it's the idea here is that you apply things to a group versus an individual, because it's more secure. There's less likelihood you'll have special cases that create security vulnerabilities. So a use case for IAM with Amazon S3 potentially could be that IAM policy, you could grant read-write list access. And then you could also have an IAM policy that grants read-write list access for the developers, and then the bucket with home directories for each employee and share for groups. So you can really use this to use IAM as well with resources. Okay, federated users. An IAM role characteristic allows you to provide temporary security credentials. It's not uniquely associated with one person. It's assumable as well by a person, application, or service, and it's used to delegate access. So use cases would be to provide AWS resources with access to services, provide access to externally authenticated users, also to provide access to third parties, and to switch roles to access resources in your account or any other account. So really, as I mentioned before, this is a best practice for deploying services into production. If it's for example, an S3 instance, an EC2 instance, you would give that EC2 instance the ability to do whatever it is you needed to do. For example, read from S3. And really the role based, I guess I can do a little demo here real quick, is if we go to IAM, it's pretty straightforward to create a role. All you need to do is go to roles and then say create role, and then it'll allow you to select the trusted entity type. We could say AWS service, and then it even has the common use cases because it's so common. EC2 and Lambda, those are the ones I use mostly roles with. You select EC2, and then you would go through and you say next, and then it says, okay, well, what do you want this role to have the ability to do? And so again, using the principle of least privilege, maybe it would be S3. You would go through here and look for it, and you could say maybe S3 read only, right? And you could have this particular EC2 instance could read buckets from S3. So you can also grant permissions to assume a role. So an IAM user application or service to assume a role, you must grant the permissions to it. There is AWS Service Token Service, AWS STS, and this is a web service that enables you to request temporary limited privilege credentials. These can be used for IAM users or for users that you authenticate, these federated users. For example, you could allow an IAM user to assume a role. Role-based access control, or RBAC, is a traditional approach to access control, and this is letting users specify permissions based on the job function. So a DBA, right, a database admin, or a distinct IAM role for each permission combination. You can update the permissions by adding access for each new resource. What's the best practice for all this? So tagging is a great way to keep track of things, and this would be a way of basically applying it to a resource across AWS accounts. You could define custom tags, multiple practical use cases, right? You could do billing, access control, like I've used tags quite a bit for things like spot instances. If I'm going to launch a cluster of, let's say, 1,000 machines, I may want to apply a tag programmatically even to a particular resource, so I know how to filter that resource and look at all the different tags associated with it. There's also attribute-based access control, or ABAC, and this is a highly scalable approach to access control. So the attributes are a key value or key value pair. So team, developers, project, unicorn. The permission policy rules are easier to maintain with ABAC than with RBAC because the permissions are automatically applied based on attributes, and the granular permissions are possible without a permission update for every new user or resource, and you can audit it as well. So how would you do this to your organization? What you would do is you would apply ABAC to your organization by setting access control attributes on identities, requiring attributes for new resources, configuring permissions based on attributes, and also testing new resources or verifying that permissions automatically apply. Okay, externally authenticated users, that's another consideration. And so identity federation is really giving you the ability to have user authentication completed by a system, let's say a corporate directory. It provides a way to allow access to existing identities without creating IAM users. And identity federation options are AWS STS. This would be the public identity service provider, custom identity broker application. Option 2 would be SAML, security assertion markup language, and 3 is Cognito. These are all 3 options. So identity federation with a identity broker, an example would be you have a user that is using the application, and that user accesses a service, and there's single sign-on. The user authenticates to a corporate identity store. The broker retrieves the temporary security credentials from STS and then passes them to the user application. With SAML, you would have user navigate to a URL. They would authenticate. They would return a SAML assertion. The assertion gives you an endpoint for SAML. They're redirected to the console. Cognito is a fully managed service that I've used before in companies, and it provides authentication, authorization, and user management for web and mobile. And it's a identity federation service. it has the ability to federate identities as well. So you can hook it up with Amazon, Google, etc. You can have user pools, so you can maintain a directory with user profiles and authentication tokens. So let's take a look at Cognito real quick. Cognito is pretty slick because you can actually have, basically industrial strength authentication by using Cognito. And so we can see what it says. It says consumer identity management service, and you can create a user pool. In this case, you can either do a Cognito user pool, and so users can sign in with email, phone, or username, or you can do federated identity, and that would be using things like Google, Amazon, Apple, and you can actually manage it through Cognito. So it's a very sophisticated service that you can use to basically manage authentication, authorization, and user management. So an example would be you would authenticate, get tokens, you would redirect back to your application, you would exchange tokens for credentials, and then from there, you would go ahead and access some service, right? And that's how a typical auth flow would work with something like Cognito, where it needs to talk to some maybe resource in AWS. Okay, what about multiple accounts? So very similar is that people would have multiple AWS accounts, and there's a couple different architectural patterns. Most organizations choose to create multiple accounts. Multiple VPCs in a single account is one option, or multiple accounts where each VPC is in each account. So maybe you would have the development account, the test account, and the production account. The reason for doing this is so that you can isolate business units or departments. Maybe you don't want your development team to push things into production without using the infrastructure as code. You can isolate auditing data and recovery, and you can separate accounts for regulated workloads. And you can also have cost alerts for a business unit. So this is typically a good idea, especially as you get into larger organizations. So what are some of the challenges though? Well, IAM policy replication can be an issue, right? If you have a certain set of things in one development account, how do you replicate those same policies, for example, in a production account? Creating a lot of accounts. This could be manual billing consolidation. So really you need some kind of centralized control if you have multiple accounts. So how would you do this? Well, one way to do it is to use AWS organizations. This is a centrally managed service that allows you to enforce policies across multiple AWS accounts. So you can do group-based account management, policy-based access, and automated account creation and management, including consolidated billing, and it's all API-based. So what does AWS organizations really do in a nutshell? It's a hierarchy of OUs, or organizational units. You assign accounts to the OUs. You define a service control policy, or SCP, and then you attach the SPCs to the root, the OU, or the account. So really it's a hierarchical permission structure for multiple accounts. Okay, so if we just go down to some use cases, characteristics of service control policies, they enable you to control which services are accessible to an IAM user. They can't be overridden by the local admin. The policies are defined in individual accounts as well. So examples of using this SCP or service control policy would be to create a policy that blocks service access or specific actions. So for example, you could say that users can't disable CloudTrail auditing, right? Because you need to see what's happening for your compliance. You could also create a policy that allows full access to specific services. So maybe full access to EC2. You could also create a policy that enforces tagging of resources. So in a nutshell, most companies do use multiple accounts to isolate business units, and AWS organizations is how you would do that. And you could control them or configure them using SCPs. So in a nutshell, I think the big takeaways here to just wrap things up are that AWS IAM users, groups, and roles are really important to know for security. And also it's important to know about federation. And also it's important to know about how to manage multiple accounts using AWS organizations. So that's really it for me today. And what we're going to cover next week is, let's see here, I believe we were on, if I go get out of here, we were on today, securing user and application access, and we'll go next week. We're going to get into implementing elasticity, high availability, and monitoring. So we're making lots of great progress. We're probably roughly halfway through here of all of the certification material for AWS Solutions Architect. So see you next week with another 52 weeks of AWS, and we'll continue working on the Solutions Architect material.